Salut tuturor, sunt Zgondea Paul, sunt un administrator de bază de date, lucrez de peste 8 ani cu Microsoft SQL Server. Cine altcineva lucrează cu bază de date de pe aici? Ok. Cine e administrator de bază de date? Cine scrie cod T-SQL? Ok. Foarte bine. Tind să cred că nu suntem așa de diferiți și, nu știu, că ne lovim de aceleași probleme la work și inevitabil atunci când nu avem pe cine să întrebăm pentru o opinie, o părere, ajungem cumva la aceleași soluții, aceleași răspunsuri datorită prietenului nostru Google și din cauza asta ne-am gândit să facem o comunitate de oameni cărora le place lucru cu bazele de date. Suntem afiliați cu SQL Pass. Pentru cine nu a mai auzit de SQL Pass, este o organizație din Statele Unite ale Americii, non-profit, și scopul lor este facilitarea comunicării pe acest domeniu al bazelor de date și mai ales pe Microsoft SQL. Vreau să mulțumesc sponsorului RIA pentru tot efortul pe care l-au făcut. Mulțumesc mult pentru logistică, resurse și aș vrea să îl invit pe Silviu Niculita să ne îmbogățească cunoștințele despre SQL Azure.
Să încerc. Ok. Mersi, Paul. Right. I'm going to switch to English. My name is Silviu. I am the Chief Troubleshooting Technology Officer at RIA. Part of my job is evaluating new and exciting technology. We do a lot of work at RIA around, data warehousing and big data and OLTP, and that's what triggered my interest in SQL Azure and how to scale out databases. Public speaking best practices dictate that you're supposed to practice a presentation at least 4 times before delivering it in public. So I'm not quite sure exactly how long it's going to take me to get through all of the content that I've prepared, but if I finish early, I've got lots of pictures of my daughter to show you guys. I'm very proud of her. She is obviously the cutest baby in the world. I think that goes without saying. So if I finish in 30 minutes, and I think I've got 60, we'll see a lot of pictures of her, right? I'm trying to start her off early in terms of her technology education, right? We're just getting started with concepts of solid principles and architecture. And she was somewhat incredulous as I was explaining that sharding might be a good way for her to solve scalability problems. And we'll see to what extent I can convince you guys, because she doesn't seem too certain of that. Right, so my objective today is going to be to hopefully convince you guys that sharding technologies in general and the implementation for Azure SQL called Elastic Scale can enable you to achieve unbounded capacity as well as elasticity on your relational data sets. My agenda, we're going to do a recap of database as a service. I just want to make sure that everybody's familiar with the concepts and with what's required for database as a service and also what's in the box when you sign up for SQL Azure. We're going to talk about some usage scenarios for database as a service and for cloud sharding. We're going to talk about some scalability strategies that you can employ in terms of scaling up and scaling up your data, your data. We're going to do an overview of Elastic Scale. We're going to try and do some demos. One of my demos I actually broke last night at 11 p.m. and it took me until around 1 a.m. to fix it, I think. So we'll see how well things go. Some conclusions at the end, and then at the very end, easy questions and good answers, hopefully, right? I like to deliver interactive presentations, so I like to encourage audiences to ask me questions. To incentivize you guys, anybody that asks a good question gets some candy. Got plenty of it, so please ask away. Anybody aware of database as a service and or SQL Azure? Okay, handful of people. I happen to know an awesome presentation about SQL Azure was delivered in Cluj by a very good speaker last December, so shame on you for not attending. Right? It essentially means that you relinquish all control over your relational database to somebody else, and then in exchange for that, they get to worry, and for some money, obviously, they get to worry about stuff like hardware reliability, software patching, maintenance, service level objectives, and that sort of thing, right? So you give them some money, and they provide you an endpoint with an SLA attached to it, and with certain limits in terms of how many resources you can utilize there. Azure SQL is Microsoft's play in this area. There's a lot of competition in this space. Amazon has their own product offering. When it comes to Amazon, you can actually choose which RDBMS flavor you want to use. So they have MySQL, they have Oracle, they have SQL Server. They even have, as of last fall, their own flavor of MySQL called, I think, Aurora, which is supposed to deliver better performance and higher availability. So there's a lot of players to choose from, which makes things even more complicated. Right, so this is clearly a marketing slide. It's supposed to provide elastic scale and performance, business continuity, data protection, self-management, and it's supposed to be familiar as well. Actually, it's SQL Server 2014 hosted by Microsoft in their data centers. That's all it is. In terms of your options to use a relational database, if you're a bit of a narcissist, you can do this. Right? This is what my team does. So we're narcissists, That guy right there in the front row, he's only 30, and he's got far too much gray hair. That's because he does this, right? I'm trying to move him up here. So save Lucian's last remaining flag here. Right, so obviously, the higher up you go in terms of layers of abstraction, the easier it is on you, right? We had an incident, when was it, Lucian? Last week or the week before? We did software maintenance on our database servers, and our last remaining single point of failure decided not to boot because the RAID array was corrupted. So we had about 2 weeks ago 4 hours of just waiting around for the data center and hitting refresh on the ticket at IBM to see if it had been fixed or not. So that's not fun, right? Ideally, you want to be up there, right? For practical reasons, we need to be down there because our databases simply don't fit in the cloud right now, but maybe with sharding, we'll be able to get away with it. One of the biggest problems that have I keep bumping back now, that have deterred us from actually adopting cloud databases have been the noisy neighborhood problem. Are you familiar with the concept? Basically, your database gets provisioned on a database server alongside with a bunch of different ones. And as long as everybody does this, in terms of their resource utilization, things are good. If somebody starts doing this, right? So DB5 is just doing a load test. They're getting awesome performance. My life sucks because I'm DB4 or 6 or 9 or any of those other guys, right? So I get impacted, right? The latest, I think this is as of, summer 2014. Everybody gets their own small bounding box. So you can't exceed a certain amount of CPU, RAM, and disk I/O, right? And because that bounding box is at the database level, that ensures a predictable level of performance for everybody that's living on a particular instance of SQL Server that's hosted by Microsoft. That's actually the resource governor that was introduced in SQL 2014. It added support for I/O, right? So you can limit the amount of I/O that a database can produce. So that's obviously a prerequisite for a good, mature, reliable database as a service. And even if you go with the competition, right, with Amazon or with Google, you want to make sure that they provide that behind the scenes. There's lots of different options. going from basic to standard to premium, all of them, interestingly enough, provide 4 nines of uptime, which is awesome. The differentiator is around obviously performance, some more sophisticated features. With premium, you get geo-replication. So you have a non-readable secondary. You can have a non-readable secondary of your database. With premium, you have readable secondaries, etc. And there's obviously a limit on how much data you can keep in every single database of this tier. Right? And there's even more granularity. Right? You can go from basic to standard 0 through 2, and then at premium from P1 to P3. They introduced a new unit of measure called a DTU. That stands for Database Throughput Unit. That's a mouthful. It is essentially a blended measure of how much CPU, RAM, and I/O your database can do. And it's supposed to scale linearly, right? So a basic database gets 5 DTUs. The biggest one they have right now gives you 800 DTUs. 10 is twice as good as 5. 200 is twice as good as a 100. Right, this is based on a synthetic benchmark that they do. It's quite interesting how they came up with this unit of measure. This will set you back about $5 a month. This one, $3,000. So you get your pick, right? This is actually an awesome deal because you can get a reasonable number of transactions through on just one basic database, and for $5 a month, you get a database that's backed up by a 99.99% uptime SLA, and it's backed up constantly, and you can go back to any backup and restore up to, I think, 14 days into the past. So it's exciting. Pricing is continuously getting better, right? So this is as of August of 2014. They dropped their prices in half. You can expect them to do this sort of thing, every 6 to 9 months. There's a bit of competition in this space, so we profit from it, or rather, the companies we deploy these services for profit from it. Okay, questions so far around database as a service or SQL Azure?
Are there any limitation on your databases on how much of the resources can you use in time? For example, I know that you have a limitation on the disk I/O, for example, but can you use the disk I/O at its maximum for about a couple of weeks or the entire month, let's say, or do
No, you get the
streaming from it directly for the entire month at the maximum speed?
There's no concept of peak, right? Like you get in what virtual machines, I guess, is what you're referring to. So you can use you can use an average of 500 megs, but you can spike up to 800 for like 2 hours. No, it's dedicated essentially. So if you provision a P3, you can max it out indefinitely, right? As long as they won't throttle you in any way, shape, or form, which is where the predictable piece of it comes in, right? Now, moving on to sharding. Why exactly would you want to do that? Right, it introduces additional complexity into your software architecture. Capacity, for one, right? Even if you're doing the on-premises thing, and you can have, these days with 800 gigabyte SSDs, terabytes and terabytes, and 4U servers, you can stick 30-some hard drives into them. There's a point where your database might outgrow the capacity of one single database server, right? Performance. Yeah, there's only so much RAM and so many CPUs you can stick in a single database server. So at that point, you have to partition your data across multiple nodes. And there's all sorts of interesting problems, especially if you're in like the medical field or banking. You might be forced to store certain pieces of your data for certain clients just in Europe, or just in North America, or just in Asia, right? This all is heavily dependent on legislation and regulation. You might want to isolate customers for one another, so you might want to have, for contractual reasons or whatever, we've had to do that. So you might have to keep a client's data on a separate physical database. In terms of the types of applications you can sort of design, there's single tenant, right? Imagine a blogging platform. Each blog gets its own database. multi-tenant, where you can have several tenants sharing the same database and they're partitioned by load or volumes of data. There's hybrid temporal data. This is especially interesting when you have, for instance, IoT type scenarios where you've got sensors out in the world or devices that are constantly producing data, right? You might imagine a scenario where you simply, new day rolls around, you provision a new database for that day's data. At midnight, you get another database and so on and so forth. Geolocation, geopolitical, as I mentioned, you might need to store data in for certain customers in certain data centers. Okay. In terms of how we solve scalability problems, there's always scaling up, right? In SQL Azure, you go from a basic to a standard to a premium down to basic, and there's also scaling out, right? Which is what sharding basically entails. You partition your data through some sort of logical mechanism, and for example, customers 0 through 100, that being their ID, right, customer ID, whatever, live in one database, 100 through 200 in a different database, and so on. And these don't all have to be the same size, right? You might have a customer that has a lot of sales orders or purchase orders or whatever, and they need better performance, so you do this or this, right? If you've got a really important customer on that shard. Okay, so scale up, scale out. Sharding terminology, there's a few terms that we're going to need to be familiar with going forward. Typically, you have a database that's dedicated to keeping track of what customer has their data in what database, right? So just the mapping between the logical key, your sharding key, and your physical databases. So that's typically a separate database there. These are going to be your shard databases. Together, they make up a shard set. A shardlet is all of the data belonging to a logical unit, right? So if you start sharding at the customer level, everything that connects down from that row through foreign keys typically makes up your shardlet. So you've got your customer, you've got their purchase orders, purchase order line items, and everything below that, right? So that whole tree structure for that one customer is your shardlet. You also have reference tables. These are the sort of tables like, inventory items, right? Or exchange rates or whatnot. These are the sort of tables that you're not going to partition, but you're going to replicate across all of your shards because you want to preserve referential integrity, right? And I think that's about it. Did I miss anything? No. Obviously, the customer ID is going to be your sharding key. Okay. Elastic scale is, well, there's multiple components to it. It is essentially Microsoft's attempt at easing access, right, for mere mortals to sharding as an architecture pattern, right? So they saw clients attempt to do this themselves, and they sort of adopted the best practices that they saw into the field, and they produced a set of libraries for us to incorporate into our applications so that we don't have to write the same boilerplate code over and over again. In terms of so these are the personas that they had in mind, right? You've got the application developer and you've got the database admin or DevOps, as it is trendy to do these days. So what comes into out of the box is an API to do shard map management. This allows you to provision new shards, to merge them, to split them, to move shards from shardlets, from one shard to the other. There's data-dependent routing. That's the piece of logic that tells you for customer ID 5, which is the database that I need to connect to in order to insert a new sales order, right? Multi-shard query. Sometimes you want to see a list of all of your customers, right? And that means you have to sort of do a select across multiple databases, and you have to do a union all across all of those selects. So this there's an API that incorporates the logic and makes it very easy for you to do that. On the DevOps side, right, the DBAs get something called a split merge service. This allows you to notice that, for example, one of your shards is getting too busy, or you might have mapped far too many sharding keys to just the one database. Let's say you mapped 100 to 200. That allows you to take 100 to 150 and move it to a brand new shard to sort of split the load. So it's sort of load balancing at the database level, right? Federation migration utility, that's probably not going to be interesting to this audience. Microsoft had a different strategy towards doing sharding. It was called database federation. So you can migrate from that to this new solution. And shard elasticity is very interesting. It's an attempt at putting DBAs out of work. So it's a set of essentially PowerShell scripts. That's what it boils down to. That you can point, it's sort of like SQL agent for Azure. You can point them at your sharding databases, and based on specific business rules, you can configure them to do certain things. Like if your database grows above 5 gigabytes, automatically upgrade it to standard 3 or whatever, right? So it automates certain maintenance operations. It's fairly interesting. Okay. You can have two types of shard maps, right? Contiguous values, so 100 to 200. That's more amenable if your sharding key is an integer, right? If you guys have GUIDs, or if you like using GUIDs for some ungodly reason, you're going to have to do explicit values. That's obviously more cumbersome because you have to keep track of where each individual GUID is stored. So that's going to make your shard map manager database larger. And you can have 4 data types for your sharding key: integer, big int, GUID. So actually just 2, because big int, GUID, and binary data. Data-dependent routing. Obviously, your client application wants to retrieve the metadata for customer ID 104. It's going to talk to the shard map manager initially, and then that thing is going to tell it, yeah, you want to connect to database too. Code to do this is fairly simple. You just need to call a specific method. You need to tell it which sharding key you're trying to query. And beyond that, it's using SQL connection. So it's sort of like a prayer at this point, right? It's ADO.NET talking to a database. Yes?
And if the sharding key is different from the where statement, then
you get candy.
what's happening?
You don't get anything. You get back. You just get, so your data reader, well, you're using a data reader. Yeah, it's just not going to return anything. Right. This just gives you a connection string, the correct one. It's up to you. If you're doing it wrong down here, it's a bug in your code that you're going to need to address. It also doesn't do any filtering. So if you specify shard key, whatever, 104, and if you leave off this clause, it's just going to give you everything in the shard. It's not going to do any sort of logical filtering for you. So there's no magic here. It's just boilerplate code that Microsoft has written for you, hopefully reliably. It's open source, so you can check it out if you don't trust them, right?
Shard map is included into .NET Framework?
No, it's just a package that you download off of NuGet. You can keep trying, but I'm not going to give you any candy. So keep asking questions. Now, the shard map itself physically is just a database, and the data-dependent routing is just, so you just open the NuGet manager and you search for Elastic Scale, and you'll just download the DLLs, and it's an API. Okay. There's obviously a lot of caching involved, right? This has been built for potentially thousands and thousands of shards. So that shard map information is obviously kept here. It's kept in each individual shard, which I thought was unusual, but it sort of makes sense. And it's also kept locally in memory, and they have cache and validation mechanisms put in place. So if you use the split merge tool to change your shard map, the client will notice and you'll actually get connected to the correct database. Multi-shard queries, as I mentioned, this is the union all scenario where you need to produce a list of all of your customers. Again, very simple, very small changes that are needed. Instead of using SQL command, you just use a multi-shard command. You specify the policy, right? Theoretically, you could have shards that don't respond in time and might time out, so you might get a partial result set back, and you tell it how you want to handle that, if you want to get an exception or if you just want to deal with whatever you get. Things become unpredictable when your customer data is across 1,000 different databases. It becomes interesting to produce your master customer list. So again, nothing major, pretty simple code. Split merge service, we're actually this is the part of my demo that I broke last night. It is a cloud service that has a web application and a background service behind the scenes. It allows you to do stuff like, you've got two shards that are fairly lightly used, you can merge them. If you got one that's very heavily used, you can split it into separate shards. Okay, demos. Right, so this is, sorry, I'm going to block your view, but I can't move this thing. So this is going to be an awesome demo. It's a console application. Whoa, right? And just so you guys can see it, I'm going to try and zoom in. So this is the Elastic Scale Starter Kit. It's a component that it's a proof of concept app that Microsoft have put together. Could have done something nice in WPF and made me look awesome, but no. They had to do console applications, annoyingly enough. And this allows you to do a couple of things. So I initialized it earlier because actually initializing can take a bit of time because it has to it produces 3 databases. It produces the shard map and 2 shards. Right, and that, producing even a basic database can take, 1 to 2 minutes, spinning it up in Azure, so I did it ahead of time. And I've got 2 shards at this point, right, so shard 0 contains ranges 0 to 50, and then shard 1 contains 50 to 100, and then 100 to 200. We're just going to add another shard at this point. 2, and we're just going to go with 300, and at this point, it is physically creating a database in SQL Azure. And if we look on my SQL server in Western Europe, and if we look at the databases, and if we refresh, okay, it's doing its thing. Refreshing this thing takes forever. And it is here, shard 2, right? And it's been added at this point to the shard map. And I can actually zoom back in. And I can try to insert some rows using data-dependent routing. So this is the piece of code that actually, what it's going to do is just generate a random, oh, nice. Customer ID, it picked 297, and that customer ID actually went to the appropriate shard, right? In theory, at least. And we can actually verify that. We're going to do a multi-shard query, right? Also option 4. So that's going to do that union all scenario that I told you about. And Microsoft Corporation with an ID of 297 was inserted into shard number 2. And we can actually check this as well, just in case you guys don't believe me. So you can tell I'm not a real DBA because I don't even have Management Studio installed on my laptop. So let's see. Western Europe. We're going to query databases, shard 2. And let's zoom in so you guys can actually see something. And this is Visual Studio 2015 preview. And this takes forever, so don't install previous software, especially from Microsoft on your production laptop. Okay, so these are sort of that shard local cache of your shard map. If you remember, I mentioned it, the shard mappings are stored on each individual shard as well to boost performance. If we look at the customers, your data, and that should open. And I broke it. It's a very large table, one row. Forget what I said about performance. No, this is just Visual Studio. It's, I think there's a newer CTP out there, but I haven't had a chance to install it yet. So this has actually introduced the customer and an order for that customer. And we also have, we also have products and regions. So these would be your reference tables. And things become very, very interesting if you've got reference data that changes frequently, because you've got to manually sort of do a distributed transaction across potentially a very large number of shards. And if one of those shard updates happens to fail, you might want to roll back. So if your reference data is extremely volatile, you might want to consider a different storage mechanism for it. You're going to have to evaluate if you want to keep it in relational or not. Or you might want to start thinking about, okay, so here we go, 297, Microsoft Corporation is in here. Excellent.
Any limitation on the isolation levels?
On the, what do you mean when you say isolation levels?
Read committed, read uncommitted. If you try to
It's T-SQL behind the scenes. So,
Anything that's applying to 2014, for
Yeah.
example?
yeah, anything that you can do in 2014 pretty much. Certain differences you can do to this thing as well.
About everything, if they support the optimistic ones like snapshot or something.
Read uncommitted snapshot isolation.
Yes, optimistic.
Well, that would be applicable, I guess, if you wanted to do readable secondaries.
If you have a highly concurrent system.
It's SQL 2014 hosted by Microsoft, so whatever you can do to the on-prem version. Elastic Scale works for on-prem SQL Server as well, right? So there's nothing cloud-specific to it. It's just that it's much more amenable to a cloud scenario, right, than it is on premises. Because on premises, you don't have that elasticity in terms of the hardware, right? At some point, you're going to have to call the data center. Listen, I need 5 new servers, and I need them in 2 hours, and they might say no, right? So that's, but yeah, you can do this with the on-premises one as well. Okay. Let's see, next demo. Multi-shard query APIs, we've done that. Data dependent routing, split merge service. Right, so this is the piece that I broke. So this is connected to the same Silviu Test Western Europe server behind the scenes, and I'm gonna have to copy and paste some stuff. And shard map manager database name, which is this guy. Probably should have pre-populated these before I started talking. Username. And if anybody is fast enough, you can technically copy my password.
It's recorded.
Yeah, I'm gonna have to change it because. Well, obviously there's a firewall for this thing, and by default it doesn't allow inbound traffic from anybody. Shard map name is this. But I obviously create a firewall to allow inbound traffic from the entire internet, because why not? So what we're going to want to do is Charlotte move. Right? I'm running out of time, so I'm going to do just the one, but split and merge are pretty self-explanatory in terms of what we do. Charlotte move is interesting. It's what people refer to as the Justin Bieber scenario. Anybody know who Justin Bieber is? Anybody who's not embarrassed to admit they know who Justin Bieber is? Let me rephrase that. Right. So Justin Bieber apparently is some sort of musician, and I had to look him up. Because I was like, what? When I heard about this. And he's very popular in like social media, and whenever he posts something to Twitter or on Instagram, it blows up and it becomes very, very popular. So let's say, Justin Bieber is customer ID 297 Microsoft, and he's so big that he needs his own special little shard. So what you can do is you can move him 297, that's setting the one, to the same target server, right? You can have multiple servers, right? That's where the geolocality piece comes in. You can have a shard in Western Europe, one in Northern Europe, and one in Australia for all intents and purposes, but I have just the two. So target server name, database name. So Justin Bieber right now is in shard 2. We're going to move him to shard, which one is the least busy? Shard 0. And he's going to be there with Fabricam, but that's fine. You could use the API to produce a brand new shard and he'd be all alone, or you could use the split merge to move everybody else off of it. So we're going to move Justin Bieber, aka Microsoft, to shard 0. We said, I think, yes, 0. And not for this site. Oh, exception. Target shard name is null or empty. Oh, target database name. Sorry. Phew. And this is the batch size, right? So if you're doing a split or if you're doing a merge, this tells it how many shardlets to do at a time. But we're just doing one, so we're going to move the one. And oh, it works. It's always promising. So this is the web front end to it, and it actually uses SQL table, Azure table storage behind the scenes, and there's a queue, and it'll do your operation. And if we do...
Does he get a new ID?
No, it's the same ID. It's actually going to modify the shard map. So if we do a multi-shard query here again, so remember 297 shard 2, and we would expect 297 to be, okay, so it's not done yet, yeah, good point. But it's already updated the shard map. So shard 2 is 200 to 297 and 297 to 298, so we broke it. So the shard map becomes interesting, but we're gonna do, let's see if it's, oh, succeeded, okay. So in theory, if we do a 4 again, so he's been moved to shard 0. So it worked. Excellent. It's always good when demos work. Entity framework, right? Anybody here use EF and not embarrassed to admit it? Now, Lucian and I have endless debates about the merits of entity framework. I actually feel personally that it is a reasonable choice if you need a fully featured ORM, and I also feel that it's not fair to compare it with sort of the micro ORMs out there, right? They just do data loading, right? If you don't have a data context that does change tracking, then you're not a fully featured ORM, and it's not fair to compare yourself with Entity Framework. So this is another sample that just shows how easy it is, another console application, sorry, to integrate with Entity Framework with Elastic Scale. So let's see, go back to servers. I've configured this thing to connect to Northern Europe, where I've got 3 databases, right? Again, shard map, shard 1, shard 2, same story. And this time around, I'm going to use, let's zoom in again, Entity Framework behind the scenes to do some simple CRUD operations, right? So this is a multi-tenant scenario where I think the default EF sample is blogs, especially on the code first side, right? So you produce your business entities and then it creates your table, something Lucian would never, ever, ever let me do. Let's do Lucian's blog. Okay, so very exciting, right? So Silviu's blog to Lucian's blog, right? So it did an insert, and then it it retrieved that data from that the appropriate database. And then second tenant, shard number 2, we're going to enter the name for a new blog. Lucian's so good, he gets 2 blogs. There we go. Yeah, again, amazing demo, right? But this is just this just goes to show that with just minimal code changes. So there is something called an elastic scale context, which derives from database context, which abstracts away that whole data depending routing piece. And if you want to look at how they actually do, where is that thing? Here we go. Okay. So this is, let me move this out of the way. And so you can fit, but now you can't see. So let's go back. So this piece here is just boilerplate entity framework code. You create a data context, create a new instance of your blog business object, you set the properties with an inline constructor, you add it to your collection, and then you do a save changes. And that's it, right? And you've got data-dependent routing built into your customized data context that will save that new blog entry into the appropriate shard behind the scenes. What's tough to do with entity framework is that multi-shard query scenario. So for that thing, for those scenarios, you're going to have to drop down to ADO.NET again, because the data model is database specific. So this is built on top of off-the-shelf EF. You could, right? Entity framework is open source at this point. It's on GitHub, so you could theoretically, if you're very, very ambitious or narcissistic or both, you could fork it and build elastic scale support into it. Microsoft would probably appreciate it, but it would be a significant amount of effort. So that's one of the limitations. But the nice thing is, if you use EF code first, you can do, it has that feature where it will update your database schema to whatever schema your business objects have. I forget what it's called. I think it's schema transitions or whatever. So that's a very elegant way. If you push out a new version of your database, you have to update the schema on all of your shards. So this is a nice way of letting Entity Framework handle that for you. The first time you connect a data context to a database, it'll validate the schema, and if it's out of date, it'll do that update for you. Programmatic scale-up. I felt it would have been unwise of me not to do a demo using T-SQL code. So we're going to try that. Don't do much T-SQL these days, but I'm going to try my best. Let's see. So we're going to do new query, which is, I think, this guy. And I actually want to, can't see anything, disconnect and connect to this guy. So certain stuff you need to do while connected to the master database. So I think we put Mr. Justin Bieber, I think, on shard 0. Which is now, if we look at the portal and we switch to our Western Europe data center, shard 0 is basic database at this point, right? So poor Justin gets just 5 DTUs, and Justin will not tolerate that unacceptable level of performance. So what we're going to do through T-SQL is we're going to move him up to standard with service objective of S0. And we're going to do S0 because migrations for basic to S0 are very, very quick typically, because behind the scenes you don't really get moved from one database engine to the other. You just get reassigned to a different resource group. That's what all that happens behind the scenes. So if we do an execute, successful, I wasn't quite sure why it was highlighting. But if we go back to let's go back to.
So they use some sort of resource governor behind.
Oh yeah, obviously. Western Europe. Databases, come on. So we should see, which one did we do? Share 0? Share 0. We should see that move up to premium, to a standard 0 pretty soon. And you can do this through .NET APIs as well, and you can do this through PowerShell as well. But I like T-SQL. It's old-fashioned. Let's see, scale, standard. There we go. So this, basic to standard and down again is typically very, very fast. If you've got a 200 gigabyte database that you want to move from standard to premium, that might take a while because it needs to find room in the data center for your database, and it actually has to move your data across, right? So it creates a replica, right, always on behind the scenes. So it creates a replica for you, and then it has to copy over your data.
So the transfer is strictly related to how big is your database, or
Yeah, it's yeah.
do they have an ETA, like a maximum?
No, it's very non-deterministic, unfortunately. So sometimes I do things and it take 20 seconds. Sometimes it take 5 minutes. Sometimes trivial things like saving the configuration on a cloud service took like a minute. So it varies, unfortunately, right? Especially when you have very big database. Yeah.
Is the shard available?
It is. During migration, it is. One thing I actually forgot to mention. It is available while you're doing that pricing tier change. It does drop your connections when it does the switchover, but that's the same thing that happens on premises. If you're using always on and you move the primary replica right from one end to the other, it'll sever those connections. And if you try to connect during those few seconds, you'll get a transient fault. I forget exactly what type of exception you get, but I think databases in resolving state, that sort of thing. So most of these samples incorporate this guy, and this is actually a best practice that I recommend you guys use, not only if you're using SQL Azure and Elastic Scale, but also on the on-premises stuff. So this is, what is it? Enterprise Library. The latest version introduced a new EAB, Enterprise Application Block, called Transient Fault Handling. And you define, well, it has a few defined for you, right? Retry policies, right? So whatever is you define in that action, right, in that delegate, it's going to try at least a few times.
Also, you don't need to specify.
No, you need to. So SQL retry policy is, go to definition. So what it'll do is it will define a retry policy for SQL database transient error detection strategy. That's a good class name there. And it will, let's see, it will retry 10 times, and it will wait 5 seconds between each retry. So, Candy. Thank you. Excellent question. So that's something we're trying to incorporate in most of our applications as well.
Can you get the specific error in case your database is in transit state? Like, I don't know.
Yeah, but if it's a transient fault, you don't really care because you're trying to mask that from your users because you're doing a failover or whatever intentionally.
How to keep it still into the waiting mode in case you don't have.
Well, that's what this does. It'll actually re-execute that action for 5 times before it actually gives up. Yeah.
I don't want to give up. If it's in
Okay,
transit
listen.
state,
I'll tell you what. you can have this. So there we go. Okay. And if this is optimized for SQL Azure and on-premises SQL. If you just want to do transient fault handling in a very elegant fashion, there's a different library on, I think GitHub or Codeplex called Poly, which is awesome. So you have anyway, that's a tangent. running out of time. So conclusions. Database as a service is growing rapidly. It's about 100% year-over-year growth. It's at, I think, it's going to be at 1.8 billion in 2016, right? So double that every year going forward. It's going to be a big industry. Sharding is a viable strategy for scaling out your databases beyond just one physical server, right? Elastic scale is a pretty robust, that's a marketing slide there, robust and feature-rich implementation of sharding for SQL Azure. It works fine except when I break it at 11 p.m. My daughter was satisfied with my explanations of SQL Azure there, right? So she is suitably content there. Sources and references, there were 3 excellent presentations about SQL Azure and Elastic Scale at TechEd last year in Barcelona. Most of the very, very nice animated slides that you saw in my presentations are taken from those slides. You can find them on Channel 9 and view the original and compare. I'm funnier than those guys, but I think they're not allowed to joke as much as I am, because that's a very expensive event, so people want to get technology, not jokes. There's a Elastic Scale documentation map, which is an excellent resource. It actually looks like a map. So you have your starting point. It's sort of like going to the mall. It's right. Tell me about Elastic Scale, an introduction and glossary. They do a much better job at explaining all of the terminology, sharding, shardlets, etc. And also questions. I still have candy, so. No? Go ahead.
How would you compare the performance and availability of these sharding strategies as opposed to, let's say, MPP architectures, such as parallel data warehouse, for data warehouse scenarios, of course?
Well, you're talking about a different league in terms of pricing and complexity. This is accessible to anybody, right? Get 5 shards, $5 a month each. The library is free. PDW is like strictly Fortune 500. I'm even afraid to ask how much licensing is on PDW, right? You need to start talking to salespeople at HP or storage vendors. So it's it's complicated. Is a good answer. So it's not. They're not really, apples and apple trees, or it's very different. Yes. No candy. Okay, other questions? Yeah.
About database, how it's a DBA, how the DBA will tackle with the concept of database growth. For example, if he doesn't estimate correctly the database growth, maybe the database can grow very large in a short amount of time, and maybe he can pass from standard to
you have the
same tools you use for a normal database.
Pretty much. So you get specific DMVs that will show you exactly how many resources you're using in each area. So how much CPU, how much RAM, and how much I/O you're doing, and those have a time delay of 15 seconds right now. So you can tell, how busy your database was 15 seconds ago, and they're working on reducing that to get it to as close to real time as they can possibly do. And the portal has some reporting capabilities and nice bars and charts as well around that area. So it's monitoring, but you can theoretically, right? You can also automate this step, right? So you can use Azure automation. It'll do scale up and scale down for you. They actually make available some PowerShell scripts that get executed by us. Remember that automation thing I mentioned? That's sort of like SQL agent in the cloud for the entire Azure platform. They can monitor those DMVs, and if one of your shards pegs the CPU for a consistent amount of time that you define, like if for 5 minutes you're at 100% CPU utilization, I bump you up one level to P2 or P3. And if you're at P3, at that point you need to do a split, and so on and so forth. And if just one And if you've moved Justin Bieber to his own shard and he's a P3 already, then you're out of luck. Poor Justin Bieber. It's at that point you sort of have to start thinking about moving your sharding level down. So split Justin Bieber's Twitter posts or whatever between multiple shards. But that's a whole different scalability problem there. Okay. I still have 2 more, so.
Can you set up alerts for this sort of changes?
Yes, you can set up email alerts, and it'll start emailing you whenever certain conditions are met. I did that once, and
What would you recommend to have a service that's actually monitoring you and let it go automatically or shrink it automatically if it's unused, or have the application on the fly doing that, or I cannot, or checking every single couple of requests and checking if I still have available space, like he said, and then moving to a different.
it's a matter of taste, basically, so you can decide if you want the application you're building yourself. So it's whatever technology you're more comfortable with. So you can do scale up, scale down through, I think, 3 mechanisms. T-SQL, which is what I showed, right? So you can do that from the application by executing T-SQL code. You can do that from your application by executing .NET API calls, or you can do that through PowerShell. Now, exactly who does that call and who does that monitoring, it's up to you. You can use their automation thing, which is sort of like Windows Task Scheduler that wakes up and executes your PowerShell script and does that for you. Or you can have your application, or you can have a worker thread. You can have anything you want. There's, sky's the limit. It's very democratic. It's exposed through multiple channels, and the way you consume that information and you react to it is also up to you completely. Okay. If that's it, then thank you. And I'm going to be around if you have any more questions.
Înapoi la română, pauză de 10 minute, veți acolo refreshment.